Okay, so let's start. Fine. So yesterday I think we finished with the operators and the statements. Fine. We did see something about the lambda expression and where we did come across interface. Okay. Anyway, details we'll be having later. Fine. About those, what is interface, what goes in interface. Right. Okay. Initially, we'll first start with looking at class. And so we'll see what goes in a class definition. So what is a class as such? It's a data type. Fine, simple thing. So class is a data type. So defining a class is like creating a new data type. And it's a programmer defined type. So programmer wants to create a new data type. So let's look at it from that point of view. So what goes in a class definition? What are the various members which can go in a class definition? Okay, so let's start by taking a very simple example. We want to have a data type to represent a rectangle. Fine, let's consider a rectangle. Okay, so we define it as a class. So your class definition may go like this, right? How do we write a class? So we'll say, okay, we have the keyword class. We have a class name, fine, and then the body of the class definition. Fine, in the body of the class definition there are various kinds of things which can be used. Okay, but let's say the most simplest thing is I don't put anything. Your class rectangle, nothing. Okay, so with this what have we done? We have created a type. Fine, we have come up with a new data type called rectangle. How can we use this? Yeah? Huh? Yeah, you can create object. Okay, so let's see what are inspired just having something like only where we say okay it's a class rectangle. Fine, just keeping this much, and what we can do still is okay we can write some application which uses this data type. So let's write some sample application which can use the data type called rectangle. Yeah. Yeah. Okay, so how do we use this, right? So just a definition, class rectangle, nothing. And now in our application, so for our application we can write a separate class which has our main method. Okay, so let's say we write a separate class and let's call the class name as class test rectangle. Okay, and in this class we'll say okay we want to have a application, so we'll say okay we want to have a public static void main, fine, with parameter of type string array. Okay, some parameter name. Yeah, so now within this let's see what can be, how we use the data type called rectangle. Rectangle is a data type, you can declare variables. Fine, so that's one thing. So we can do something like this, rectangle R1, R2, that's allowed. Just because my definition is nothing but just class rectangle, nothing inside it. Declaring variables, fine. Another thing, we can create objects. Okay, fine. Variable is not an object, fine, that we know now already. Having a variable means yes, just a reference. There's no object. To create an object, we use the keyword new. Okay, so if you want, you can have R1 equals assigned to R1 by allocating an object of rectangle. So with the keyword new, fine. We can, this is for creating an object of the class rectangle, and that's how you create an object of a class. So if you have a class rectangle, oh, you can create object like this. Fine. Usage of a class which has nothing. Okay, and then we'll see as we add more something into the class definition, there are more ways we can use it. Fine. Okay, fine. So we are able to create objects. What else do you think is possible? From whatever we have seen yesterday, any of those things? You can have a string conversion. Fine. We can use equals. See, there's nothing here, right? But we are able to use so many things. We even can allocate an array of this type, right? Okay, fine. Someone can say r1.to string. This is valid. Fine. Someone might say, okay, let me have r2 also something. R2 equals, maybe he says r1, or he might allocate another different object. That's also possible. And then he says, let me have r1 dot, let me print what is r1 dot equals r2. Equality. Fine. When we saw this, that yes, the operator double equal to is only about whether it is same, whereas if you want to know about equality, there is a method called equals which should be used. When we are not currently looking at what result it will give, okay, when what kind of results we get is a different thing altogether. We'll see, we can control the result, because this is the type which we are defining. We'll define how what the result of equal should be. And currently we haven't put anything in the rectangle class definition. Fine. So usage wise, you have created a new data type. You should be allowed to create objects. Fine. You should be able to make equality. You should be able to have a string conversion. String conversion is available for every data type. Every data type. Okay, fine. Then, so fine, this is a very simple thing. Fine, you could add more things as you like. It's up to you. So this is a main method. You can use it for testing the type rectangle. And if you have more different ideas, yes, you can apply them. Okay, fine. So that's the initial version. Now the next version of the class rectangle. So the next version says, let's have our class rectangle. Okay, so that's one version, right? Okay, we've defined this class, but now let's add a few members into this. In a class, we can have variable declaration. And in my class definition, I can add variable declarations. Every rectangle would have length and width. Okay, fine. Let's keep them of type integer. And we are declaring them as integer. So we can say, okay, class rectangle has one integer for length, another integer for width. Okay, so that's my class integer, class rectangle. Okay, now I have got length and width as two variables in my class definition. Fine. So with this definition, what's being allowed? How we can use this now? Okay, I'll not write the things. I'll just straight away write the content which goes in a main method. Fine. Okay, fine. Okay, let me just show that. Fine, what I'll not be writing from now onwards, I'll keep on having different definitions of rectangle, but I won't write this full. This is something you should understand. Yes, there is a class called test rectangle, and test rectangle has the public, static, void, main method with parameter of string array. Fine. So we are inside this method now, and we are writing the content of the main method straight away. Okay, so in the main method, how we would like to use the rectangle type? So we can declare variables. It's a type. Every type you should be allowed to create and declare variables. Okay, next, creating object. Fine. Let's create R2 equals new rectangle also. Fine. So we have two objects being created, one for R1, other for R2. Okay. Then what else? Oh, we got those length and width, right? In rectangle, fine, in the rectangle class, we have got length and width. And therefore, someone might say, well, let's have a print of system.out.println. I want to print what? Rectangle has length and width. Okay, so let's try printing rectangle.length. Yeah. So what will it do? Okay, let me add one more thing in the class definition. Let me make some change. Okay, we are declaring int length. Okay, and what is also allowed here is when you declare a variable, you are allowed to give some initialization. Otherwise, the default initialization will be 0 if it's a numeric type. So let me put int length equals 5 by default. Okay, yeah. So what would be when I say someone says let me print rectangle.length, what should it print? Yeah. One answer is 0. Yeah. Other answers? Hmm. Yeah. What should it print? Rectangle.length. Okay. What are these things? What are these variables? These variables are known as instance variables. When it says instance variables, what does it mean? Length and width are nothing but instance variables for the class rectangle. This is a definition. Class is simply a definition. Fine. When it is saying I have an instance variable length, I have an instance variable width, what it says is if there will be an object of rectangle, then that object would have a length and a width. Length and width do not exist without an object of rectangle. There is no length, there is no width without a rectangle. If there is a rectangle, it has a length and a width. Every rectangle object has its own separate length and width. Okay, every object has its own separate length and width. What am I trying here? Rectangle dot length? What is rectangle? Is that an object? No, this is not valid. Rectangle dot length is not valid, it won't compile. Okay, fine, we can't use something like rectangle dot length. Length is declared inside the class called rectangle. Fine, it's an instance variable. It's supposed to be used with object only. Without object, it doesn't exist. You cannot use it without an object of the rectangle type. Okay, fine, clear? That's not valid. So, what's the change? Instead of this, we might be using R1 dot length. Yeah. You declare a variable length, right? You declare a instance variable length, an instance variable width. What is the additional way of using it? If I have an object, I'll be able to use dot length and dot width additionally. Earlier I was also using dot toString and dot equals, and yeah, some of the there are so many other things also which we have not, but yes, what is the additional thing? Because you have length and width, yes, if there is an object, you should be able to use length and width. Remember one thing, length width cannot be used without the object of rectangle. Anywhere. Okay. Anywhere they cannot be used without the object of rectangle. Let's see this. Okay, so you can print R1 dot length, R1 dot width, and initial value. How is this? When is the length and width going to be allocated? When is the space for the length and width allocated? When the object is created. So when someone says R1 equals new rectangle, let's see this, what's happening. So if someone is saying R1 equals new rectangle, and if we execute this statement, R1 equals new rectangle, this is declaration rectangle R1, R2, you can think there is R1 and there is R2, these are the two references. When someone says R1 equals, this new rectangle is nothing but creation of an object. When the object is allocated, what is allocated? The space for the instance variables. There are two instance variables, so there is space for two variables, two integers. The space for two integers is allocated. Fine, first integer is length, second integer is width. And R1 equals, so R1 has to refer to this object. Fine, when it is initially allocated, fine, this values will be 0. When someone says new, the value is 0. After allocation, as soon as it is allocated, another thing which it has to do is, it has to execute any assignment which has been declared for the variable. There is one variable for which assignment has been declared, and therefore what will happen here? This 0 which was at the time of allocation is being set to the value 5. Okay, it's when we declare, it is nothing but asking it, as soon as you create an object, make the assignment. Fine, object creation and assignment should be done. Okay, fine. Another object, because we used new for the second time also, yeah, we have another new. Okay, so that would mean another object creation. Fine, it's almost the same thing, nothing different. R2 is referring to this object, this, okay, initially 0 set to 5 later, and that's how it would be. That's our picture. Fine, instance variables, fine, separate copy for every object. Someone could also use like this. Someone could say, well, let me have r1 dot width equals 3. Fine, r1 dot width. Oh, r1 is referring to this object. So in this object it would become 3. In the other object it is still 0. When every object has its own separate copy of the instance variable. Clear? Instance variable. Okay. Instance variables may have a assignment statement also. If there is an assignment statement for an instance variable, it will be executed as soon as the object is allocated. Fine. After an object is allocated, it executes the assignment on that object. Okay. Fine. The next thing. So now, okay. So object has a structure. Object is like a structure. Fine. It has some structure. Okay. Object has a interaction. You would like to interact with the object. Fine. We already have one interaction like toString. But anyway, we would like to add our interaction. So when we define a class, in a class definition, okay. So in our class definition, so our class called rectangle, okay, we got those two variables, length and width. Fine, I'm assuming those. Okay, length with the assignment of 5. Let's keep it that way only. Yeah. Or okay, let's forget the assignment now. Fine, we understood what the assignment is for. So let's forget the assignment. It is simply int length and int width. Okay, those two are declared. We know now if there is object, we will be able to say dot length and dot width for it. Now next thing is we are saying, okay, if we have a rectangle, we should be able to ask the rectangle what is your area. Fine. This interaction will be with the object. So this area is going to be there as a method. So a class can have a method. Right? In a class we are declaring a method. The method's return type here in this case can be a int. Name of the method is area. What parameters? You got an object of rectangle. Just think, you have an object of rectangle and you want to interact with that object and ask what is your area. And you are interacting with the object and saying, what is your area? Do you have to pass any information? There is no information to be passed. This will be without parameters. It's going to be without parameters. Okay. Now comes the important part. So if someone says area, someone's interaction is area, I want to get your area. Fine. What's the code for that? How do you write the code? It has to return an integer value. So yes, we'll have a return statement. Return what? Length. Which length? Huh? Can length be used without object? No. Tell me which object's length. Huh? One thing, okay, I'm keeping it halfway, fine. Usage wise, if I had that object R1, fine, can we use rectangle.area? Is that okay? No, and it's not okay. We need some object. So this, how is this behavior going to be used? It could be used on any object, right? You need some object. It could be R1 dot area, it could be R2 dot area. Area used on different objects. Fine? Okay. So within the area method, when you write the implementation of area, in this area, fine, in this method, you would like to refer to the object on which this method is currently invoked. Area is not used without object. Fine, area cannot be used without object. It needs an object. There is a target object with which it is interacting. Fine, so that object is available. Fine, so if someone is calling area, he is actually also calling area on some object. So that object would be available by using a keyword called this. And we have the keyword this. What's the type for this? What's the data type? What's the data type? Inside the class rectangle, what's the data type for this? Rectangle. Fine. Same type as the class in which it is being used. Fine. Okay. This dot length. Okay. This dot length multiplied by this dot width. Now, one thing here is our compiler is making a few conveniences for us. Here, if you don't use this dot length and simply say length, and if you just simply say length, it won't give you an error. And it won't give you an error. Instead, it will make the changes like this for you. Clear? So length, though you may say length, if you just say length, fine. Length is, there's nothing called length here, right? There's no length in this method, right? Is there any variable called length in this method? No. It should give an error. But instead of giving an error, it makes the adjustment and says, oh, I see there is some instance variable called length, so you forgot to use this dot length. I'll put it. The compiler is making the change. Okay, the compiler is making the change. Fine, it becomes this dot length. Fine, if you say width, it becomes this dot width. Fine, instead of giving error, it's only, I won't give error here, right? Okay. Length and width could have been valid. Let's see another example where that becomes valid also. So this is one kind of an interaction. Clear? To know the area of a object of rectangle. Right? Now, yes, from usage point of view, what can be used? If I have an object R1, I can say R1 dot length. I can use R1 dot width. I can also use R1 dot area. Fine. See, as we add members here, it's about it is making this data type rich. And it is becoming richer in terms of how it can be used. Fine. There are less ways of using it. Now we have more things, more kinds of interactions. We are adding more features to it. Okay. Fine. So you are defining a data type. Remember this. Fine. Defining a class is like creating a new data type. Fine. So a class is not a program. It's not a sequence, right? It's not something in a sequence you follow. Fine. Where is the sequence? What's the sequence being followed? The main method. The content in the main method. That's the step by step what I am following. This class definition is simply, and these are just members in a class. It's just describing that if there will be an object of rectangle, it should be having two variables. If there is an object of rectangle, let's allow an interaction with its object for fetching the area. Let's allow the interaction for its object for setting the values of length and width. Let's have a method to set the values for length and width. Okay, let's have a method called set dimensions. Fine. So we have a method. Let's add one method here. So we add a method Okay, this method is about setting the values. It's not returning any value. Okay, so we have the method with return type of void. Name of the method is set dimensions with parameters being integer length and another integer for width. Fine. Now you can see what's to be done when someone says set dimensions. This set dimensions is called on some object. That object's length should be set to the first parameter. Fine. What's the first parameter? Length. Fine. Here, if I use length, it would mean the first parameter. Length would mean the first parameter inside this. It's never going to be treated as the length, which is the instance variable. And the two are different. Okay, fine. See here, when someone says length, it's not an error. Here, if someone just said length, yeah, it's an error, but it doesn't give an error, makes a correction. It will change to this dot length. And here, so now what is it that we would like to do? Assignment on the object. So object's first instance variable length, this variable should be assigned the value from the first parameter. So we should be saying this dot length equals length. Yeah, length here is my local variable, parameter variable. Fine. Same way we have this dot width equals width. Okay, fine. So that's the set dimensions. Okay. Okay. So next thing. Fine. So this is okay. Yeah. Now we understand how the things can be used in main. What are the usages? Declare variable for rectangle, create objects, use methods, use variables also. Fine. R1 dot length, R1 dot width, R1 dot area, R1 dot set dimensions. Fine. R1 dot set dimensions, and you give two values. Okay. Now someone says, let's have a convenience here. Instead of giving two values, if someone gives only one value, it should mean that we want length and width to be the same. Okay. Fine. You want to set the length and width to the same value. Fine. So we might add another method. Fine. We don't need to give a different name. We can continue with calling it as set dimensions. Okay, which has only one parameter, that is what is the side. Fine. Side. And yeah, what this does, I can use the earlier method from here. I can invoke that earlier method. Fine. But that method is set dimension. I want to call from this particular set dimensions, the earlier set dimensions, giving same value for both the parameters. Fine, to invoke that I need to pass two parameters. I'll pass same value in both cases, but this requires, where do we invoke the object, the set dimensions method? We invoke it on object of rectangle. Which object of rectangle? And this dot set dimensions, side comma side. Fine. And we have the set dimensions side comma side. Clear? But of course, method means on an object. Fine. Whatever we are defining is to be done on object. Fine. This is the definition in the class rectangle, and all your definitions are about objects. If there is object, then this. Without object, none of these things. Okay, so that's your implementation. So that's our next version of rectangle class. Fine. Usage I have been discussing, but still we can repeat, or we can add more members now. And we have seen what kind of members now. What kind of members go in a class definition? We got instance variables, and we got methods. Okay, these are also methods, but then something about this method, this is known as method overloading. Oops. And it's method overloading, and that's known as method overloading. Okay, let's extend further then. Fine, let's look at more requirements which we have. Okay. See, one thing, in the usage point of view, when I am using this, the first thing which I do is I'll say new. Fine, I create object. When I create object R1, oops. When I create object and say R1 equals new rectangle, okay, if this is what is being done, what's happening? Yeah, object is allocated, and that object has length and width. Okay, and what are their values? It has length and width, and they are set to 0. No, I don't like this. One second. Okay, so when we do this, it allocates a new rectangle 0 by 0, and we don't like this. See, a person is able to create a rectangle object just like that. I just want to create a rectangle. If you want to create a rectangle, give me some specifications. Give me what you want for length and width. Unless you tell me what is the length and width, I don't create a rectangle for you. You want to put a restriction like this? Fine, unless you are giving me length and width, I am not creating it. Fine, and that can be done, okay, when we make this next change. Okay, let me do. Fine. So the next change here is okay. Yeah. So next thing, the next kind of a member which goes here, we call it as actually a constructor. So we can add a constructor in our class definition. So a class definition has instance variables, it has methods, and it can also have a constructor. A constructor is like a method which does not specify a return type. You don't mention a return type for the constructor. Fine, there's no return type. Fine. Okay. Otherwise, it's just like and the name has to match the class name. Fine, name matches the class name. Okay, and then we have parameters. So constructor has parameters just like a method has. So here we can say, okay, I would like to have length and width. Okay. Fine, we are defining a constructor. So constructor is basically nothing but a very special method, okay, which is used as soon as we are creating the object. It's only used at that time. It's the first method for any object. Object is allocated, fine, the life of an object starts, and the first thing happening in the life of the object is invocation of the constructor. Fine. There are interactions with this. So first interaction, okay, I have to do this. That's the task of what is defined in the constructor. Fine. So what we do in this case here is, we'll say, okay, the first thing I would like to do here is this dot set dimensions to whatever is the length and whatever is the width. That's it. Okay, once you put this in your definition, once we have a constructor like this in our class definition, the earlier thing which we had written, what was the code earlier? Okay, let me show it what we had done earlier. Earlier we had that class test rectangle. What did it do? Oh, it had done this, right? It said new rectangle, and that doesn't work any longer. This stops. In order to create a rectangle, two integers, because I have a constructor which says I need two integers. Fine, new is used for invoking a constructor. But then this was working earlier. We didn't put a constructor. How was this working? How was this working? Let's go back to the very first definition which we had. Here, even in this case, this was working. There's nothing inside this class. Every class has at least one constructor. Every class has at least one constructor. When you have not put anything, the compiler puts it. Okay, what the compiler did here, when we didn't put any constructor inside, the compiler automatically added one constructor which was a public constructor for the class rectangle without any parameters, and the code for that was, okay, we don't do anything here. This is the code for the default, the no argument constructor, which by default gets added. Fine. When it finds, when the compiler finds, oh, you don't have any constructor, oh, every class needs a constructor, it will always try to put this constructor if there is no constructor found in your definition. Okay, so if a class does not have a constructor explicitly mentioned, that's a constructor which comes. Fine, so usage point of view, something which was working stops. Okay. Yeah. So your class definition, see this class definition which had nothing, still so many things worked, right? Yes. Yeah. So one thing was constructor, because there was, at least the compiler was doing this for us. Okay, so let's come back here. Okay, so the constructor, fine, we have added a constructor in our class definition. Okay. Again, execution point of view, how is the execution done? When someone says new rectangle, what is done? Now, okay, let me just put it here. If someone is saying R1 equals new rectangle, okay, he has to specify two integers because there is a constructor here. Fine. There's only one constructor here, so it says if you have to create objects, you need to give me two integer values. Let's say he says 7, 5. Okay, creates an object of 7 by 5. Fine. Now one thing, how the execution exactly happens? First thing, when someone says new rectangle, allocation is taking place. Allocation was initially 0, 0. Okay, then if there was an assignment for the instance variable, that would be carried out first. If there is any assignment for the instance variable, that is carried out first, and then it looks in, okay, oh, I have to look for the constructor in this class definition of rectangle which has two parameters, which is taking two integers. Oh, there is one. Then it starts invoking this. Before the invocation of this happens, okay, before the invocation of this constructor happens, it has done the assignment, if there was any assignment mentioned. Assignment and then this constructor. Okay, fine. Or you can think, fine, or you can think in like this, that though we write a constructor in this manner, in this constructor, if there is any assignment which has been mentioned, it is actually coming as a statement here. It's added as a statement.
Yeah. How can we call a set dimension method rectangle?
In
Rectangle will be called at the very beginning.
Okay, the object has been allocated 0, 0. The object has been allocated, the life of object has started. In this life, the first thing done is use a constructor.
The compiler will know that set dimension will be there.
Who is executing it? Runtime, not the compiler. Compiler has to check the syntaxes. And syntax checking, okay, this is available. In rectangle, I can use this because the object is already allocated and then the execution starts. Fine, so I have some allocated object, okay, fine. Set dimensions is there, available, invoke it. That's fine. Okay. Fine. Clear how the execution happens? Okay. And then we have this one invoking set dimensions and set dimensions in turn setting the values to 7 and 5. Okay. So this dot set dimensions, when it finishes, value has been set and there's nothing more to be done in the constructor. Okay. Now again, just like we provided a convenience overloading for the set dimensions, we can have a convenient overloading for constructor also. So like we can overload, okay, I didn't mention here. So this is nothing but this is a constructor. Okay, and then you have in your class definition another thing which can be added. Let me remove this. Fine. Another thing which goes in the class definition is overloading of constructor. Fine. So we have the constructor being overloaded. It takes single integer, the side, and now another thing. What we want to do here is, instead of invoking another set dimensions from the constructor, I have one constructor. I already have one constructor. I would like to use that constructor here. I am overloading the constructor. So the existing constructor which is here, I would like it to be invoked from here. How do I invoke the other constructor? Rectangle? Huh? Rectangle, and then you can have a method called rectangle. Okay, in the class rectangle someone says I want to have a method called rectangle. Constructors are identified because they don't have a return type. If someone makes this change and says, oh, I'm putting void here, then it becomes a method. It won't give a compilation error. Okay, putting a return type of void, oh, that's not a constructor, it's a method. The class rectangle gets a method called rectangle. Okay, fine. So that's something which is allowed. Okay, you can have a method by the same name as a. So what would be the difference between calling the overloaded constructor or calling the method? Fine. So from that point of view, no, we don't use the name here. Fine, we don't use the name. And to invoke that other constructor, we will use the keyword. There is a keyword called this with a set of parameters. So it can be used only in a constructor. This followed by a invocation of giving parameter values, passing parameter values. So here I am saying side, comma, side. Fine. I'd like to do exactly what is done in the earlier constructor by using the same value for both the parameters. Fine. This and parameters. This is used only in a constructor. This with a parameter list is used in a constructor for invoking the overloaded constructor. Another thing about using this for invoking constructor is it can be used only as the first statement in the constructor. You can't have any other statement coming before this. If you are writing a constructor and you want to invoke the other constructor, do it first. Then you can have other statements. Fine, you can't have any statement coming before this. Fine, if this is to be used, it should be the first statement in the constructor. When in our case here, we don't have any additional statements, but just think if there was some additional task to be done, I would like to do whatever is in the other constructor, but I am also interested in doing some more steps. If I have few more steps, they can't come before this. This has to, if this is used, it's the first statement in the constructor. Fine. So, yeah, what members go in a class definition? So that's your overloaded constructor. Fine. Okay, so now, okay, so this is one thing, right? So now you know what can be done, how we can use this definition. We can create object, fine. We can use the instance variable on the object, only on the object. We can use methods on the object, fine. Okay, and that's what we should be doing, right? Create object. And normally it's not encouraged to use variables on the object. Of course, there are certain things which we will be learning later on, which is about access specifiers. So the accessibility to length and width should be not allowed, should not be allowed. Something like that should be done. Encapsulation, we would like to enforce encapsulation. Okay, currently we are not enforcing. Okay, fine. But when we learn about access specifiers, we'll do that. Okay, fine. So it's normally create object and start the interaction. Okay, methods are more important for us. Fine. Variables would not be important because methods, they define how you will interact with the object. Variables are supposed to be private. Fine. Variables are supposed to be private, so there would be restricted access to them, and allowing us to change the structure whenever we want. When you change the structure, others would not be affected by it. Okay. Anyway. Okay, so now another requirement we have. Now someone has this requirement. Okay, yeah, one more thing. Let's look at another. Now let's look at a main method, some piece of code, and then we'll have the next requirement. Fine. Fine. Now we have the next piece of code which says the way we are using is like this. So we use something like this: R1 equals new rectangle of 7 by 5. Okay. Then it says R2 equals new rectangle again of 8 by 3. Okay, and then someone says, maybe he prints a few values and then says, let me have R2 equals R1. Okay, so what exactly is happening? We have R1 and R2. R1 is assigned a 7 by 5. R2 is assigned 8 by 3. And then later R2 is equal to R1 would mean R2 stops referring to this one and starts referring R1. What happens to this? It's a memory leakage. It's a memory leakage, right? So what should be done? Before you change reference, you must deallocate Fine, in C++ we should have been doing like that. Fine, if you have a pointer to an object, fine, and you want to change the pointer to point to a different object, the earlier object you should do a dealloc and then only change, otherwise there's a memory leakage. And you have to worry about memory leakage. In Java, you don't worry about it. See, there are problems associated with that deallocation. What's the problem? If we do that deallocation, there can be sometimes wrong deallocation. You know what could be happening? Okay, fine, I'll just try to show the problem which could be occurring. Okay, the kind of problem which you have is, you have one, let's say, I'm saying pointers, okay, this is not reference, this, let's say C++ pointers. So there is in C++, there's one pointer, there's another pointer, and there are 3 pointers here. Okay, this is P1, P2 and P3. When this is one object, okay, that's another object. And this are both referring to the same one, they are pointing to the same one, this is pointing here. And now the person who is looking after this one says, okay, I'm now going to point to a different one, but he doesn't realize that there's someone else also pointing to the same object, P1, P2, P3. Okay, P2, P3 is the same object. Fine, and then the one who is doing this job, because, oh, I'm changing my pointer, I should deallocate the current one. What he does? He deallocates this memory becomes free, and he points here, and what P3 is pointing. And then somewhere in the code he says, later on he says, P3, from P3 let me get access to the member through P3. And when he does this, what happens? Code crash. Yeah. Okay. C++, C and C++, the pointers. Dangerous thing. And the errors there, find the errors, because it's like, you know, people may not be able to manage pointers well. So what Java has done in this case is, it says, you don't worry about references. Fine, you don't worry about it. Deallocation, I will do it. There is this Java virtual machine. Fine. Java virtual machine, a feature of Java virtual machine is, it's a multi-threaded environment. It's a multi-threaded environment. What do we mean by multi-threaded? Okay, multiple things executing simultaneously within the Java virtual machine. So what is it? What are the multiple things it is doing? One thing which it is doing is, it is executing the application, it's executing the main. While the main is executing, it is simultaneously also executing another kind of a code which is known as the garbage collector. So it has, Java has what we call as a garbage collector. And it's not the code written by the programmer. Of course, some programmer did it, but not the normal application programmer. Fine, but it is written as part of the JVM. Fine, it's part of the JVM. So we have this garbage collector. Okay, so we have the garbage collector. Yes, what is this garbage collector's role? Fine. So from time to time, it can go and look for objects which are not usable. Fine. For this, what it is doing is, it's actually looking at all the reference variables, right? Any reference variable which is available, any references which are, all the references which are there, it uses those references and marks out the objects which can be reached from the references. Okay, So that's the first phase. In the second phase, it says, oh, which are the objects which were not marked out? They are the ones which are not reachable and they need to be deallocated. So it's known as mark and sweep algorithm, and we call it as mark and sweep algorithm. Fine. First phase, mark out whatever is reachable from the references. Okay. Whatever remains unmarked is the one which will have to be destroyed. So in Java, object cannot be destroyed by a programmer. It is only destroyed by the garbage collector. Deallocation. When I am saying destroy, here I mean the deallocation of the object. The space to be deallocated is only possible by garbage collector and not by the programmer. Now what we have here is, see, from main we are able to invoke method on our objects. So given any object, I can interact with that object and we can write code for interaction with the object. Right. Same way, even garbage collector is going to be having those objects. Fine, garbage collector has access to the all the objects. Okay. So when this garbage collector has access to the object, now one thing what has been defined is that if the garbage collector is it has found that this particular object needs to be deallocated. Fine, if it has located some object which needs to be deallocated, what it would do is the garbage collector would invoke a specific method. Okay, there is a special method available, okay, which you can put in your class definition as something which can be done by the garbage collector. So there is this method, return type is void, name of the method is finalize. Okay, but one thing here, this method, if you have to write in a class definition, it has to be declared to be either a public method or it may be a protected method only, nothing else. Either public or protected. And at this moment, just okay, note this, the meaning of public and protected will come later. Okay, but yes, we have this method called finalize which can go in a class definition. Okay, so what is this method? What's the purpose? Before destroying the object. Fine. If someone calls finalize, what does it do? If someone says r1.finalize, because finalize becomes a method in a rectangle class, if someone says r1.finalize, what would happen? Does it destroy the object? It's just another method. Fine. See one thing, we have this method which is not supposed to be used from the application. It is meant for the garbage collector. It's not meant for the application to ever call the finalize method. Fine. The one who is writing a definition of a class is putting this method in the definition. Okay. It is there as a interaction from the garbage collector. The garbage collector is the one who is going to be using it. It knows this. It's a garbage collector which will be calling this method before it is destroying the object. Fine. So in the main method, no, you should not be saying R1 dot finalize or R2 dot finalize. If you call this, yes, it will simply call that method. Fine. And then, oh, it was never anticipated by the one. So the one who is defining the class, remember, see, there are two types of programmers. One programmer is the one who creates a data type, and another is the one who is using the data type. The one who defined the data type is having the assumption that this method is not going to be called by the application programmer. He only thinks that this is going to be called by garbage collector before it is destroying the object. And the method is written from that point of view. Fine. So someone calling finalize, then don't complain if the class misbehaves. There is no guarantee of things working properly once you call finalize. And it's not supposed to be used by the application programmer. It is supposed to be used by the garbage collector only.
Isn't recommended to use finalize method in the type behavior?
To use finalize, okay, that's what I was mentioning, that we have two types of programmers. One is the one who defines the class, other is the one who is using it. The one who is defining, he defines it, but don't use it, don't call it. That's the idea. And no one is supposed to be calling it.
So you can't declare finalize method as a private.
No, because then the garbage collector would fail to access it. Fine. We have the garbage collector who has to use it. Okay.
So the garbage collector will see if the finalize method is there in the type.
Mhm.
If it's not, then don't finalize method will be called.
Then the finalize method will be called. Clear? The idea is clear? What is this finalize method? Before the object is deallocated, this method is going to be invoked by the garbage collector. It's only the garbage collector who can destroy the object. And before object destruction, deallocation, call this and then deallocate. Okay, so sequences, fine. So in the life of an object, fine, coming to the life of the object, first the allocation, the very first thing is constructor. Then various methods may be called on it. Then ultimately maybe it gets dereferenced, no one is able to reference it, and the garbage collector comes across it and decides to destroy. So the first thing is constructor and the last thing is finalize. And in the life of the object, last thing could be finalize. Of course, it's possible that in the application till the end, this object was never deallocated, so finalize may not be called. And then the application may get over also, right? And that's possible. Okay. But if ever it is going to be deallocated, finalize is going to be the last method for it. Okay. Fine. So now we go further in our class definition and think about another problem. Fine. Now someone says, oh, I would like to know how many objects do we have in the memory for a particular class. How many rectangle objects exist in memory? That means how many objects of rectangle have been allocated but not yet deallocated. If you want a count of that, how can it be done? We want to keep a count of how many objects of rectangle have been allocated but not yet deallocated. And so how do we get this? Okay, so what we think is there should be changes in two places. One is we'll have a constructor Okay, so we'll have the constructor. Fine. For example, I just show the changes. Okay, so in the constructor, it was saying int length and integer for the width, and it was a constructor. Fine. So in this constructor, it says, oh, let me have count plus plus happening here. Fine. Count is going to be some variable which gets incremented. Fine. And then the set dimensions may be called, that's okay. But then we also have maybe as a public method void finalize, no parameters, in which I'll do a count minus minus. I'll add a method called finalize in my class definition. Fine. Finalize is a method for the garbage collector. Instruction for garbage collector: before you deallocate, do this. Fine. So currently I use it for managing my count of rectangle objects. Okay. Yeah. Fine. So where do I declare this count? We have a need for a variable called count, but where do we put it? Huh? In the class, along with the length and width? Okay. See, this has not to be part of the object. This variable called count is not part of the object. Fine. It is not linked to the object. Whether object exists or not, I have a count. Initial value should be 0. Now in Java, you're talking of global. So unlike C, in C, yes, you have some global area. Fine. You can declare variables which are global. In Java, a Java file has only 4 items. There are only 4 kind of items. So it has to go somewhere within those 4 only. It can't be at the top level. There's nothing. Even the main had to be inside a class or an interface or a enum. Okay. So inside any of those, yes, we can have some things. So till now, whatever we have done in our class definition for rectangle, we have been doing something. We have been defining things which are, if the object of rectangle is there, then this will happen. If there is an object of rectangle, then it should have a length and width. If there is an object of rectangle, there will be area. You can invoke area, you can invoke set dimensions, but they are all about objects. They are all talking about object. Count is not about object. It is not part of the object. It is not something on the object. Okay, fine. So if you want to use anything which is not associated with the object, we have a keyword called static. As soon as you use the keyword static, you are not talking about object. Everything else in your class definition is about object. You see the method called main is static, and that's why you don't have to create the object of hello world in order to run the method main. There's no object creation happening for hello world. There's no object of hello world required for main, because that's there as a static. So anything which is static, it says, okay, I don't need an object. No need of object. Fine. See, throughout your class definition, there is one keyword which we have been using so far, That was the keyword this. Throughout your class definition, you have this. As soon as you use the keyword static, that's the part where you don't have this. You don't have this. Okay. So keep these in mind, okay? So what's the difference between static and non-static? This is the difference between static and non-static. Isn't it? This, it's not there in static. This is there if you are not talking about static.
Include any static variable in the objects.
Yes, you can, but not the other way around. Okay, I was mentioning that length, width, area, they all need object. So within my class, okay, let's see this. So I'm continuing with the class definition for rectangle. Okay, so now here I declare static. We are using the keyword static int count. And we have the keyword static int count. Okay, so that's your, we call it as a class variable. Okay, if we have a class variable, anything which is static, right, it is not linked to the object. How do I use count? From outside the definition of rectangle, class name, rectangle dot count. You don't say rectangle dot length, you don't say rectangle dot width, but count is rectangle dot count. So from that way, it is a global thing because there's only one way of using it. It's inside rectangle and count is there. Fine, but length and width, no, that can't be saying, you can't be saying rectangle dot length or rectangle dot width. When it is static, yes, it's used with the class name. So that way, global, fine. Class name dot member. Yeah.
What if we do as rectangle dot mean?
Yeah. We do
As rectangle class name dot mean method.
test rectangle dot mean, but you need to pass a string array. That's fine. So for example, from the main of hello world, you are just saying test rectangle dot mean and passing that same string array here. That's okay.
So JV will treat as the normal method.
It is a static method. Yes, it's a method which is to be invoked. Fine. Okay, so this is static int count. Now, it's a class variable. We also have a class method. So we can have a method which is static. Fine. For example, here I add a static method. Because later we might go for encapsulation and make that private. So we might have static int get count. Okay, and this one says return. Okay, now one more thing before I go into this, the code for this. It's very important to know here that you are writing a static method. Fine, what's the difference between static and non-static? This. In area method, I could have said length. Fine, in area method, I can say length because we have this available. In this method, I cannot use length. Just saying length, not allowed. Why? Length has to be with object. Which object? There is no this. It's a static. Static is not used on object of rectangle. It's not used on object. Okay, static is not used on any object, and therefore we can't just say length. If you allocate rectangle R1 equals something, R1 dot length is okay, but not simply length. Clear? Inside a static, you cannot use non-static straight away. Non-static can be used only if you have an object. You have some local variable object allocation creation taking place, and then on that object use that thing. So always objects have to be there to use anything which is non-static. Static does not require object. Clear? Length would not be allowed. Okay. Or someone says, oh, let me just solve area. No. This dot area. Oh, there's no this, sorry. You have to have some object and then dot area. Clear? Fine. See, it's in rectangle, it was okay if I had said return length into width. Fine, it was okay because it anyway, compiler will make the change, it will make it as this dot length into this dot width. But it's actually a good habit to use this. It's always a good habit because whenever someone is reading the code, the programmer who is looking at your code, he immediately realizes that this is actually an instance variable because you have said this dot length. He knows this is an instance variable straight away. And he doesn't have to look here and there. Oh, is there some parameter by this name? Or is there something else? Or right? Because you have said this, it's known, it's an instance variable. So it's actually a good practice to use this, though it's not mandatory. Okay, so there will be so many places, but fine. So follow those kind of practices. Okay. Okay, so get count, yeah, this may be simply saying return rectangle dot count, or simply even if you say count, it will become rectangle dot count because count is a static variable, and you can write this as a static method in your rectangle class. Fine. Okay, so what kind of members go in a class definition? Instance variables, class variables, or the static ones? And those are the variables. Then we can have methods, we can have static methods, and we can have constructors. Okay. Fine. Now, here, yeah, count is okay, right? This count thing. Now, someone adds another constructor. Suppose someone adds a few more constructors in my class definition, and in this class definition, if you see, there are two constructors already. The second constructor was invoking the first constructor, and therefore the count plus plus which is happening is not required in the second constructor. Someone adds a constructor and now chances are he forgets to use count plus plus, and nor does he call the other constructor. Then what would happen? Count is not managed properly. Now you have some requirement which says, okay, whenever any object of rectangle is going to be created, I want this piece of code to be executed, independent of which constructor you take. You take constructor with one parameter, constructor with two parameter. I'm not going to put this code anywhere there. This is common across all constructors. You have some code common across all constructors to be executed. Fine. That count plus plus is one such thing. Okay, whether you do this constructor or another constructor, any constructor even which may be added later on. you have some piece of code which should be executed, and for that what we have is known as a initializer block. Okay, a class can have an initializer block. Simple block. Just a one member is a block. If you add a block, okay, this block will be executed whenever any object is created. What is the sequence? When an object is created, when we say new, allocation, initially zeros. If there are assignments, that's the next thing. And once the assignments have been executed, this is the next thing which is executed, the initializer block, and then the constructor code. Just before the constructor, just before what is in the constructor. Actually what's happening is the constructors are modified. When you put your initializer block, when you put the assignment, it modifies the constructors and adds those as the initial statements. It modifies the constructors and puts those as the initial statement. Fine. So this is nothing but an initializer block. For example, what I might do here is I'll say count plus plus over here and remove the count plus plus from the constructor. Fine, I'll not do it in a constructor. It's common, whatever constructor you take. I can remove this. Fine, and put it in the initializer block. Okay, fine. So this we call as now another thing to look at, right? Okay, we have instance variables. What's the place for initializing the instance variables? Constructors. We use constructors so that we can initialize give some initial value for the instance variables. Fine. We have got class variables also, right? Where should we initialize the class variables? If there is some initialization needed. When can we do that? When are the class variables actually getting allocated? Okay, let's see when the space for count would be allocated. Okay, what is exactly happening? Okay, when we say, when we execute the test rectangle class main method, and as it executes the main method, what it will come across? It will come across that there is some class called rectangle. You have variables r1, r2. Okay, just declaring variables doesn't have a requirement that I should load the class. You have just variables. Okay, the compiler has already, if the compiler has compiled this code, it would mean those are some valid classes only. But now, as soon as you use something from that class definition, what could that something be? Someone could be saying rectangle.count, someone may be saying rectangle.getCount, or someone may be just calling the constructor. Fine. It would require the Java runtime to load the class definition. It has to read the class file, load the class definition. So we have something called class loading which happens. Every class file which is being used in an application needs to be loaded. When it loads the class definition, it would have some space allocated for the class definition. It's not the object of this class, okay? It's not R1, but the definition, the dot class file which was compiled has been loaded, right? It says, okay, oh, this class has the name called rectangle. This class has so and so constructor, so and so method, so and so variables. The whole definition is loaded. And it is this place where you got space for your class variable. Your count is here. Okay, so allocation of your static variable is taking place when your class is loaded. There's only one copy. It doesn't load multiple copies of the same class. There's one copy of a particular class which is loaded. It's not going to be loaded again and again and again. So your class variables are here. Allocation at the time of loading of class. When is the count coming into existence? When the class is loaded. Okay, fine. That's first thing. Okay, so when the class is loaded, at that time, I want to have some code to be executed so that I can initialize my variable. Or I need to read the value of count from a file and then initialize it. By default, it's going to be 0. Fine, by default, your static variables are going to be 0. Okay, but if you want to do your own initialization, right, just to indicate that what is the purpose, let me put this here. Okay, so in your class definition, what you can also do is you could add another kind of a member, right? So in the class definition, along with the initializer block, what we have is another kind of a block which is known as a class initializer block or simply a static block. And this is a class initializer block. Okay, fine. Just to indicate the purpose, I'm just mentioning it's not mandatory you should have done this, but I'm just saying count equals 0. Okay, anyway it would have been 0. It's a redundant statement, but yes, it shows that this is a place for initializing the class variables. And we use this block to initialize our class variables, because as soon as the class variables are first allocated, this is the code which will be executed. Fine. So you can use this for initializing your class variables. So now, what goes in a class definition? What are the various members which can go in a class definition? Instance variables. Examples are length and width. Then we can have class variable. Example is count. Okay, fine, doesn't require object. Fine, then we have methods, examples, area, set dimensions. Okay, we can add few more methods like get length, get width, those kind of methods can be added. Then we have constructors. We have overloaded methods, we have overloaded constructors. Fine, and then we also have a special method called finalize, fine, which is used by the garbage collector. We can have a initializer block and we can have a class initializer block. Here what goes in a class definition? The various kinds of members which go in a class definition. Fine. Okay, and so that's about what is there in a class definition. So yeah, any questions now? Yeah.
We have int length, int width with object, and
They are instance variables in a class definition. Okay.
we have object, new object created with reference of R1.
Okay.
We are using R1.toString.
Okay.
And what is the output of the string?
Yeah. What is the output of the string? try it out. You should be trying it out. I would like you to try out and not give the answer now. Answer will come very late. Okay. But yes, it will be having something. It will do a string conversion. It works. Okay. And yes. And what will be the result if I have said R1 equals new rectangle of 7 by 5, R2 is also another new rectangle of 7 by 5, and I am saying R1 dot equals R2. Okay. When you expect it to be equal, right? But then the answer will come late. But things to try out, yes. They work, right? Equals works, toString works, toString also works, equals also works, but we never defined it. We define it or we don't define it, it works. So that answer comes late. Okay. Yeah. Fine. So we'll continue tomorrow then.